This video is over lesson 94, graphing pairs of inequalities on a number line, and it is for my pre-algebra classes. So ladies and gentlemen, before we get into pairs of inequalities, we're going to just start with single inequalities all by themselves, just to review. So first of all, we have x is greater than 0. So we make our number line, and we treat this number here like the boundary. It's the boundary between which side of the number line are our solutions on and which side are they not on. So where are the solutions and where are the numbers that are not the solutions? So we put that number typically in the middle. Now, is 0 greater than 0? Well, no. So remember, in this case, we use what's called an open dot. The open dot means that this is not one of the solutions. However, the solutions are going to get close to 0. They just can't be 0. Now we need to consider which side are our solutions on. Well, since this is greater than, is -1 greater than 0, or is 1 greater than 0? Well, obviously it's 1, so the solutions are anything on this side of 0. So we make this part of the number line bold, and then don't forget to also make this bold. Now don't be shy about this. Make it obvious. Don't go crazy. Don't make it sloppy and messy, but make it bold, make it obvious, make it visible. Moving over to my next example here, this is x is less than 5. So we want to put 5 in the middle as our boundary. So if that's 5, then I've got 6, 7, and this will be 4, 3 over here. Is 5 less than 5? No. So again, an open dot. So greater than and less than both result in open dots. Now is 4 less than 5 or is 6 less than 5? Well, obviously it's 4. So in this case, since this is less than, it's going off here in the directions where the values are less than 5. I want to get right up to that open dot. Next, we have x is greater than or equal to -2. Now remember, this isn't two separate questions. This is one question. So greater than or equal to, as long as you can say yes to one of those, then we just say yes in general. So first of all, -2 is going to be my boundary. So -2, that means this is a -1 and a 0. That makes this a -3 and a -4. Now is -2 greater than or equal to -2? Well, since we can say yes to one of those things, we can say yes in general, which means that this is a closed dot. If the part that we made bold is where the solutions are, and this is a solution, then it should be filled in. So closed dot when we have an or equal to. Now is -3 greater than or equal to -2, or is -1 greater than or equal to -2? Well, greater than things head off here in this direction. This is where we find things that are greater than -2. And then for my last basic one here, x is less than or equal to 1. So I'm going to put 1 in the middle as my boundary. That makes this 2 and 3. In this direction, that makes this 0 and that -1. Since it's an or equal to, we're going to have a closed dot. -1 is less than or 1 is less than or equal to 1. Now, which side do we find our solutions on? So is 0 less than or equal to 1, or is 2 less than or equal to 1? Well, obviously it's 0, so head in the direction of 0. So those are the basics. We're now going to take a look at some and statements. So we're going to start with x is greater than 25 and x is less than or equal to 40. In an and statement, and requires these to both be true at the same time. So an and is going to produce what's called the intersection, or it'll be the overlap of these two individual graphs. So I'm going to leave a little extra space than I normally would and put my number line down here. Now 25 to 40, I don't want to count by ones there. I'm going to be counting for a while. That's too much. I'm going to count by fives instead. And I want a little bit of space on each end. So I'm going to make this actually 20. So that my second tick mark will be this boundary at 25. So then this will be my 30. This will be 35. This will be 40. So that's where my other boundary is. And then we'll go just a little beyond it to 45. So that's a pretty good number line for this. Now, real quick, if we think about this, so we're going to do some red pen above here. If we think about this, x is greater than 25. Well, first of all, since it's greater than, that would be an open dot at 25. And since it's greater than, it would then head in this direction. X is less than or equal to 40 would be a closed dot at 40. But then since it's a less than, our values would be headed in this direction. So the intersection, the and, is going to be the overlap. So where do these two overlap? Well, they overlap in between these two boundaries. This is where they overlap. So on my graph, I'm going to have an open dot at 25 because it's greater than. I'm going to have a closed dot at 40 since it's less than or equal to. And then the solution to this pair, since they're joined by an and, will be their intersection. It'll be just the space on the number line in between them. That's where we find the numbers that are greater than 25 and less than or equal to 40. So that's the idea of an and. Now, with an and, I can do a little extra with this. If we consider for a moment, if we were to flip this around, we'd end up with 25 is less than x, and x is less than or equal to 40. So ladies and gentlemen, when you find yourself in a situation like this, where you can reword this with an and, so that way the x's are both in the middle, we can take this and slide it together. And so the result would be 25 is less than x, which is less than or equal to 40. And so this statement right here is actually equivalent to this statement up here, which means this graph would also be the graph for this. Now, a couple checks you need to do about combined statements like this. One, you need to make sure that your inequalities are pointing the same direction. So these are both less thans, that's good. The other thing you need to check is, if I were to take out the variable, is this still a true statement? So is 25 less than 40? Yes, it is. So with those two checks in place, it looks good. So if I were to graph another one like this, so let's say I wanted to graph, let's just go, let's go 10 is less than or equal to x, which is less than, less than or equal to x, which is less than 15. So if we were to graph this out, this is really an and statement. It's an intersection. 10 is less than or equal to x, which is less than 15. It's really saying that x is greater than or equal to 10, and x is less than 15. So I'm going to start here. I'm going to count by ones this time. So 9. So that'll be 10, 11, 12, 13, 14, 15, 16. Ooh, just perfectly enough space. I'm going to make my 0 a better 0 there. Okay, so there's my number line. So I've got my two boundaries and x is in the middle. So 10, since it says or equal to, is going to be a closed dot, 15, since it's just a less than, is going to be an open dot, and then x, the values, are in between. So those are nice and easy to graph. These, we should think through these just to make sure that they do overlap, but these are nice and easy. Well, there's another type of pairing. You can pair with an and, but you can also pair with an or. You can also pair with an or. So this time, let's say that x is less than 25, or x is greater than or equal to 40. So if and produces the intersection where they overlap, or produces the union, and the union just put them together. Just put them together. So I'm going to make my graph here. Again, I'm going to count by fives. So 20, 25, 30, 35, 40, 45. Make that a little bit longer to put my arrowhead on. All right, that looks pretty good. So real simple, or put your boundaries in. So this lower boundary here, this less than 25, is going to be a open dot because it's just a less than. X is greater than or equal to 40, so at 40 is going to be a closed dot because it says or equal to. And now we just got to graph them. So which direction is x less than 25? Well, going from the 25 less than would be to the left. For x is greater than or equal to 40, so going from 40, greater than would be off towards 45. And there it is. So in this case, the or just says put them both together. So you got this one together with that one. That's your graph. So what we see with ors is ors give us the option to leave out the middle. All right, and with that being said, I'm going to flip my paper over, and I'd like you to please grab your books, and we are going to take a look at the practice problems. So for practice A. So graph the inequalities on a number line. I'm going to start by copying the problem. So negative 3 is less than x, which is less than 3. So here, I'm going to save myself a lot of time. And since these are both 3's, I'm going to count by 3's. So I'm going to make this a negative 6, a negative 3, middle will be 0, positive 3, positive 6. Since these are both less thans, it means that both of them will be open dots. And since x is between them, the solutions are between the boundaries. That's A. B, x is less than or equal to a negative 3, or x is greater than or equal to positive 3. Ors are nice. Remember, ors are the union. So I'm just going to graph them separately. So again, 3 and negative 3, I like that. So negative 6, negative 3, 0, positive 3. I got those negatives stuck in my head. And positive 6. Now both of these say or equal to, which means this time both of my boundaries are going to be closed dots. So coming from the negative 3, this is a less than or equal to. So less than or equal to would head down to the left there. And then coming from the positive 3, it says greater than or equal to, so that would go off to the right. C. 5 is less than x, which is less than or equal to 10. So 4, 5, 6, 7, 8, 9, 10. I always like to have at least one extra number in every direction. So I'm going to extend that a little bit and get an 11 on there. All right, so boundaries. Since this is a less than, that will be an open dot at 5. And then since it says or equal to, this will be a closed dot at 10. And since the x is in between these two, the solutions will be in between those boundaries. And that's C. Moving on to D. D says that x is less than 0 or x is greater than or equal to 5. So if I go ahead and graph this, I'm going to start at a -1. So 0, 1, 2, 3, 4, 5. Oops, again, didn't leave enough room. Need a little bit more. 6. So or, remember, just means we're going to graph them both and put them on the number line. So x is less than 0, so this is going to be an open dot at 0. Less than is going to start taking us towards the negatives. Don't forget to make your arrow bold as well. Over here, x is greater than or equal to 5. So it's since or equal to, we'll have a closed dot at 5. 5 is included as a solution. And greater than is going to send me towards my 6 there. And on and on and on up. And that's D. And last one, E. A college will cancel a lab class if less than 12 students enroll. No more than 30 students can enroll in one lab class. Write an inequality that shows the number of students that could be in a lab class and illustrate this inequality on a number line. All right, so here we go. Since it'll cancel if it's less than 12, that means we need 12 to be the minimum. So 12 is less than or equal to x. So there'll still be a class if there are 12 students. So we got to say or equal to. No more than 30 can be in the class. So if we can't have more than 30, it could be 30 though. So this will be less than or equal to 30. Now when we go to graph this one's going to be a little bit different. Real world problems sometimes create extra problems for us, extra issues. I'm going to put my 11 on here. But the trouble is, when I put my 12 on and my 13 on, obviously we're going to have a closed dot at 12. And our solutions are going to be between 12 and 30. The problem that we face here, though, is can you have 12 and a half students in the class? Can you have 12 and 2/3 students in the class? No. So in real world problems, sometimes we need to consider what are the limitations in the real world. And the limitations is you can only have full students. You can't have half a student, which means that instead of bolding the entire line, this time it's actually going to be a series of dots. So you could have 12 students. You could have 13 students. I could have 14 students, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That's 24 right there. 25, 26, 27, 28, 29, 30, 31. So I could have anywhere up to 30 students. So 15, 16, 17, 18, 19, 20, 21, 22, 23, there's 24, 25, 26, I already have 27, 28, 29, and so could have 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, or 30 students. But we can't have half a student. We can't have a fraction of a student. And so instead of filling everything in between 12 and 30, it's a series of dots between 12 and 30. So be careful about those real world problems. Consider what is the trouble there. And that, ladies and gentlemen, is the end of our lesson.